So let's think a little bit about waves. And the classical notion of what a wave is it's a disturbance traveling through a medium. Disturbance traveling through a medium. So what do we mean by a disturbance and what do we mean by a medium? Well, we could come up with some fairly simple examples. Let's say that I have a little puddle here. So that's my little puddle. And let's say I were to drop a stone in that puddle. So this is my stone. It gets dropped in the puddle, and we've all seen what happens. Right when it goes into the water, that pushes that water down, pushes the water around it out, then that water comes back up, and then you have this traveling disturbance. These kind of rings start to radiate outward from where I actually dropped the pebble. And you can actually see them move outwards. You can see the crests of those waves move outwards. So when we're talking about a disturbance, well, this is that disturbance. The pond was completely flat, but then we agitated. We pushed it down. It pushed the water outwards, and then that pushed the water next to it, up and down, and it traveled outwards from the point of that initial disturbance. So we have this disturbance traveling through the medium. What's the medium here? Well, the medium here is the water. And the initial disturbance was the rock disturbing that water, but then that water disturbed the water around it, which disturbed the water around it, so that disturbance kept traveling through the medium. And we can give other examples of this. If I take let's say if I were to take a really long string and hold it right there, and that's my hand. So the string is, let's say it's just attached to something. So let's say it's a really long string, and right now there's some slack in it. It's attached to a wall. And let's say that I were to start moving my hand up and down. So I move my hand up and down. What's going to happen? Well, let's just think about if I just did it once. If I just did it once, what I'm going to have is this lump of string move from the left to the right. So that's what it's going to look like at first. Then a few seconds later, it's going to look like this. It's going to look something like this, and you're going to have this disturbance, which is this wave, this lump that I just generated. It is going to move to the right. What's the medium? The medium in this case is the string. It is the string. And what just happened there? Well, when I jerk the string up, I'm disturbing those string molecules right next to my hand, and they're pulling on the string molecules next to them, pulling on the string molecules next to them, and so then you have this traveling lump. So once again, these are both examples of waves, disturbances traveling through a medium. Now I can give through a medium. I can give other examples. Sound waves. What causes sound waves? Well, you have a bunch of air particles all bouncing around at actually surprisingly fast speeds. But if you disturb them, if you cause something to, say, compress a bunch of air particles right here, so these air particles get ultra compressed, some type of clap happens, so these get ultra compressed, well, then they're going to bounce on the ones next to them. And so once again, you have this disturbance traveling through the medium. In this case, the medium is the air. The medium is the air. So now that we've seen some classical notions of waves, let's think about something a little bit more mysterious, and that is the notion of light. We do believe light definitely has wave-like properties. Light can interfere with each other, and we could do a whole other videos on light. If I were to take a barrier like that with two small slits in it, and if I were to shine some light, one way to think about it is these slits are the only place where the disturbance gets through, and then it would cause the light to propagate from each of them like that. And maybe I'm just drawing the crests of the waves, but it also come out from here. And so you could see where the two crests meet, they're going to constructively constructively enhance each other. They're going to constructively interfere. And if you were to put some type of detector, right over here, you would see the bright points of the light, and you would see the dark points of the light. So light definitely behaves like a wave. I'm just showing even just one example of light behaving like a wave. But if it is a wave, well, that means it needs to be, or if we use our classical logic, you would say, well, that means it's a disturbance traveling through a medium. But what is that medium? We have light coming from our sun. We call it sunlight. We have light coming. I keep wanting to make it actually our sun is white. We tend to draw it as a yellowish color, but that's just because of what happens as it goes through the atmosphere. So you have the sun, you have the earth. This is not drawn to scale, and somehow that light is able to reach us over 93 million miles. Over 93 million miles. What's it going through? Is it a disturbance traveling through a medium? Well, for a long time, people said, well, it must be. It has these wave-like properties. It seems to be traveling with a velocity, the speed of light. So there must be a medium that it is traveling through. And people theorized what this medium is. They called it the luminiferous ether. Let me write that down because it's a fun word. It's a good name for a band. Luminiferous, now I'm not spelling it right. Luminiferous ether. And there was this idea that maybe even in the vacuum of space, you have this substance, this luminiferous ether that the light is traveling through, that it's somehow it's a disturbance in that luminiferous ether. Now, what we're going to do in future videos is we're going to test that. We're going to see if that's actually the case. Because what's interesting about if there is a luminiferous ether, well, we're not going to be stationary relative to that luminiferous ether. In fact, we're orbiting around the sun. The sun is orbiting around the center of the galaxy. There's no way that we're going to be stationary relative to that luminiferous ether. So if we're not stationary relative to that luminiferous ether, we should be able to detect how light behaves if it's going kind of in the direction of ether or if it's going against the direction of the relative movement of the ether relative to us. So anyway, I'll leave you there. This mystery of science. Waves, disturbance through a medium. We saw that with the water, with the air, with the string. But what about light? Is there a luminiferous ether? Put a question mark there.